So, hi, Justin. What was your first computer?
Hi there, Adam. My first computer, I was lucky enough to have an original Apple
Ah,
IIe that I got. I don't know what year that would have been, 84 or something like that,
oh,
when I was
so
quite young.
you're not, like how to call it, a very young, hotshot JavaScript developer. So,
Well, yeah, I like it. Think I'm
yeah,
a
that's
very
what I
young
also
hotshot
what I
JavaScript
also
developer.
think about me. But Apple II is not like the M1. This is yeah. But what you did with the machine?
Y- Yeah. Um, well, let's see. I did some animation stuff. We had a little converter box that let us hook it up to our TV, so we had color, and I forget what the resolution was back then in HGR mode, if I recall. So I remember doing things like making fireworks animations and the kind of screensavers that Windows used to have with the
Yeah.
two lines moving around and leaving trails. Yeah, so I used to do stuff like that. And then eventually I wrote a word processor at one
Oh,
point.
so you didn't play
Um,
any games. So you started seriously with this stuff.
well, I played games, but it was kind of hard to come by games back then, right? Like my older brother would get um, floppy disks from wherever. We had Sea Dragon and Wizardry and stuff like that. Eventually, we got more published games. Actually, one fun fact is one of my first published games was Pinball Construction Set by Bill Budge, who I ended up sitting really close to
Oh,
at Google in San Francisco, and so I got to meet one of my childhood programming heroes and have lunch with him a bunch and stuff. So that was
yeah,
that was very cool.
that is really incredible. Something like this. So you started. So again, so if you got the computer, you started immediately gaming, or immediately doing something seriously with it. So what you said is there were no games available. So you were forced to do something more serious, right?
Yeah. So my dad, I'm a lucky kind of second generation
Okay.
programmer. My dad's a programmer too. He wasn't trained in school. I think when he was coming up, they didn't really have computer science degrees, so he was kind of self-taught. I think he started at Visa, and they needed people to program things there, and they just
Hmm.
didn't have enough people. It's like, hey, do you want to program? Sure. So when we got the computer, yeah, there were a couple games around, but mostly it was like my dad was teaching me how to program. I'm sure the very first thing I did was like, print hello on line 10 and line 20, go to line 10. And I was just like, oh, I can make it do an infinite loop. Sweet. And, from there, like programming the computer itself kind of was the game for
So,
me, I
but
guess.
you did most of visual stuff. You said like screensaver stuff like that, right?
Uh, yeah, I mean, that was the most fun stuff. I also remember trying to do those, I forget what you call that category of games, like Bard's Tale or whatever, where it kind of like describes to you the room you're in and you take some
Ah.
actions. Basically, just like a huge if
Hmm.
else tree. But I never had the patience to write that much content to make one of
So I
those
had a
work.
podcast with a guy who
Yeah.
he is now Java backend developer, and it did similar game. And what he did, he contracted his sister, to write the content, which was a genius. Nice.
Yeah.
Okay, so the first what you did. So I mean, this is incredible. So you started with programming almost immediately and played a little bit, but you created the screensaver, and now you try to start at least with a game. And what happened then? So, what was your first more interesting app you wrote? And which programming language? I assume Basic, right?
Basic, Apple Basic, yeah. My school had like a Commodore
Mm-hmm.
PET on a cart they could wheel into classes, but I was never really comfortable with the Commodore. I don't know. I had a very interesting kind of relationship with computers coming up. I was very, very lucky to be in a good school system that had, or still has, a famous computer and science and math
Mm-hmm.
magnet program. Um, so yeah, I remember one of the first more serious programs I wrote is I wrote a spell checker for a teacher because I had gotten detention and I kind of convinced my way out of it by saying that I could write this spell checker, and it was probably a very, very bad spell checker at the time. But then, I got very lucky and I got into this magnet program in Maryland, right outside of DC, and they taught us, computer science fundamentals starting in seventh grade.
Mm-hmm.
Um, so from seventh grade through high school, I had a large portion of like a college level computer science
Okay.
education, um, and that was really amazing, actually. And then I went into a period where I thought, I didn't want to follow in my dad's footsteps. I was kind
Okay.
of rebelling, so I actually didn't pursue computer science for a while. I did music and art, and kind of moved out to California and was kind of avoiding that. But when I came out to California, the startup scene in the first .com boom was so kind of intense at that point that looking for a job out here with my background, it was like clearly the best job I could get was if I did computer stuff. So,
you enjoyed programming, or was it you were forced by your parents, more or less?
Oh, no, I loved it. I took to it immediately. I just kind of, had a late teens, early 20s rebellious streak where, in some ways I thought the best thing I could do for the world was not be productive, right?
Okay.
Like producing art would have been better for the world than increasing, industrialist capitalist productivity. I guess I'm not really following that route anymore, but, I thought it was kind of an ideological rebellion, I still loved computers. And I spent many hundreds of dollars on compilers just to have for my own. But yeah, I was avoiding the profession.
And what kind of music you created?
I would say it's like jazz funk, probably more on the
guitar
funk side.
Or what?
Yeah. Keyboards, mostly electric piano and organ and stuff.
So now back to programming. Yeah. So which programming languages you actually programmed with? So you started with BASIC, then I guess assembly, and then?
Actually, I never did much assembly. I kind of went from BASIC in grade school to like Pascal in high school, and I was programming on Macs in school. I forget what language exactly we were using. On my PC, I used Turbo Pascal and then Turbo C. Once I started working again, though, it was straight into Java. Java had just come out, and I was working for a company that made multimedia CD-ROM titles. For industrial training and stuff like that, computer-based training. And they wanted to move online. And the only way you could do anything decent online then was with Java Applets. So I was doing Java for a very, very long time until I did a few years of Python. I really, really enjoyed Python and Django, and that's when I got into the web.
Do you enjoy Java?
And then when I got to Google, it was back. I do like Java. It has its areas that it's kind of, has well-known critiques for verbosity and stuff. But I always felt that was a little bit more of a choice on the programmer than something required by the language. I haven't gotten to use Java in its more recent years with more concise lambdas and type inference and stuff like that. So it's I'm sure it's a lot better than I remember it.
But back then, so what I understood was you're a fairly sophisticated programmer, so you were interested in compilers, and then you saw Java. So if you know other programming language, Java may appear too basic or whatever, verbose. So what was your reaction to Java back then? You remember?
I mean, I honestly wasn't that sophisticated of a programmer. I basically, at that time, if you actually knew how to program, there was such a demand for it. If you actually just knew how to program a little bit, right? So I didn't, know a lot about the difference between, say, type systems and, interpreters versus compilers even, and just-in-time compilers and all that. I didn't really know about that. But, I could follow the instructions to download Java and get started and write a hello program and, eventually get an applet working. And it was just more kind of sticking with it and forging ahead and buying a book for anything I didn't know. And I don't know, I felt Java was pretty approachable at the time. I mean, certainly more so than C.
Yeah, and you started with Java 1.1, I assume, right? So Java 1.0, 1.1, something like that?
1.0. I mean, I started before 1.0 was final. I remember there were some betas for a little while.
Like me, yeah.
Yeah.
I have to admit, I was a little bit confused about the applets. So I never understood the purpose of applets. So I started a little bit with applets and then moved to the server side and stick on the server from the beginning. But applets at the beginning say, why we need applets, right? So this was more, but your background was more, art and multimedia. So this was more natural to start with applets.
Yeah, there was no way to do interactivity, kind of client-side interactivity at the time. I think Microsoft's DHTML, hadn't even come out yet. I'm not sure if JavaScript, I kind of forget my timeline there. I do remember...
there was LiveScript. It was almost at the same time, and the deal was that if, let's see, if Netscape is allowed to rename LiveScript to JavaScript, then Sun is going to be allowed to ship, applets with Netscape, something like this. This was the deal. So, yeah.
Yeah, and Microsoft called it JScript or something like that, I think. It was, yeah. And I remember the incompatibilities were kind of insane. Like, so the system I wrote was a multimedia authoring
Uh-huh.
system in Java. So you would describe, it was actually a wild system. You would write this training content in
Okay.
FrameMaker,
Mm-hmm.
Adobe FrameMaker, and it had a format called Maker Interchange format where it would
Mm-hmm.
export all this stuff, and it was very much like
Uh-huh.
SGML kind of stuff. And then we would translate that
Mm-hmm.
into a Java applet. Um, and so the system I wrote like wasn't an app; it was like
Uh-huh.
an app making system itself. And there would be crazy things like difference between Microsoft and Sun, where like the Z index
Mm-hmm.
ordering was like
Okay.
opposite. Like on one of them, a higher Z index was in front of, and the other one, the higher index Z
Mm-hmm.
index was in backup. So we'd have to do hacks like, okay, if we're on Microsoft, reverse
Okay.
all the Z indexes. Um, and it was just a wild, yeah, like, and in Java, you can't, there's no monkey patching,
Mm-hmm.
there's no fixing this stuff.
Yeah. Yeah, exactly. As a problem was
So,
in the JScript for Microsoft soft, there were even some APIs lacking. Like I remember, I think RMI and JDBC. Yeah. So what you did after this? So you stick with the company for a long time, or how you transitioned to Python and why?
so this was a small startup that, wasn't very sophisticated on the business side. And I was one of the early employees, and I had traded like salary for
Mm-hmm.
stock options, and that trade ended up not
Mm-hmm.
working out very well because being kind of unsophisticated on the business side, it became clear to me that they they weren't going to have a good
Yeah.
exit. So eventually I left that company to
Uh-huh.
play music, and then I kind of went into a
Okay.
10-year music and school a hiatus. And during that time, I was doing consulting
Okay.
to pay the bills, and had some friends rave about this new web framework
Uh-huh.
called Django. This is when frameworks were all server side, yeah, and I picked up Python, and I fell
Okay.
in love with Python. I thought the syntax and the conciseness and the standard library were
Actually,
amazing.
back then there were battles
Um,
between Python and Rails, right? So I remember it was around 2006. You said it's at 10 years, so it should be in this uh,
yeah,
years. And there were even online sessions like the DHH versus the Django's guys, and they had pros and cons, Rails versus Django. And you ever did Rails, or you always stick with Django?
Django was really kind of like cured some
Mm-hmm.
skepticism I had about this approach because I had looked at Rails, and I know people love Ruby, um, but I just could not get over the
Yeah.
syntax. And I think I have a more mature view of syntax now, which is I'm like, you'll get used to any syntax if you use it long
Mm-hmm.
enough. But it's kind of the same problem I've had with like
Mm-hmm.
Haskell and other
Mm-hmm.
languages too, like lacking commas or optional things, and like is something the name of a function or an argument to the function, and the at syntax, and just a whole bunch of stuff in there got me going like, I don't know. I just wasn't
Mm-hmm.
comfortable with Ruby. So when I saw Python, it was like, oh my gosh, this
Mm-hmm.
is what I wanted. You know, and I thought Django's approach too, with the way they did views and meta models, like a lot of stuff just made sense for me. I thought that ORM
Uh-huh.
was amazing. So I really fell in love with Django
And Django is
right
still
away.
popular, still around?
I believe so. I think a lot of those frameworks had a little bit of a tough transition once things started going very heavily
Yeah.
Ajax and
Mm-hmm.
client side rendering, because you don't need as much of a server side
Yeah.
framework that you need
Mm-hmm.
API endpoints. I haven't kept up with them, so I
Okay.
don't know how they've kind of evolved to fill that
So what happens
need.
after 10 years, vacations?
Um, you know, music went okay for a while. I was with a touring band, made a couple albums, but even at that point, we were playing instrumental funk jazz. It's like kind of the party music, not something that consistently
Mm-hmm.
pays the bills there. So I had to get a job at a music store, and I was working that for a while, just kind of questioning like, what am I doing? And I decided to go back to school. And luckily, I was living in Santa Cruz at the time, and UCSC has a really amazing computer science department. There's a great community college down there, Cabrillo College. So I went back to community college. I did well and got my guaranteed acceptance program lined up to go to UCSC. So yeah, I was on the 14-year degree program. So I went back and got my degree. And then another very lucky coincidence for me, a friend there was good friends with a
Mm-hmm.
recruiter at Google. So I graduated, started doing consulting again, and then got a call
Mhm.
from Google. And this was also at a time where Google was much smaller, and I think the
Mhm.
mystique was larger. This would have been around
Okay.
2008. And it was like, oh my God, Google's calling me? Like,
Yeah.
of course I'm going to take that call. Of course I'm going to interview. Yeah, and I got a job at
How
Google
hard was the interview?
doing Java. It, it's hard to say. Like, I keep talking about how lucky I was. This is another case, like, because I was on this unusual path where I went to school again later. These interviews are a lot
Yeah,
easier
you're
if you've
right.
come
Yeah, all
directly
the
out of
algorithms, data
a computer
structures is
science
what you
background.
do all the time, right?
Yes, yes. Also, I had gone back into consulting a little bit right after I graduated, so my schedule was
Mhm.
super flexible. And I took the CLRS, the
Mhm.
algorithms book, and I took 2 weeks and didn't do any
Mhm.
contract work. And I studied the book and I wrote hash tables and red black trees and all this stuff from scratch. And I kind of went in there. I was very confident. I was ready to go. And even then, the very first question I got, it's a banned question now because it's pretty well known. But I basically froze for what felt like
Mhm.
5 minutes. Like my first interviewer was not like very welcoming or warm, or didn't try to put
Okay.
me at ease. He was just like, okay, here's a problem. Try to connect these concepts and just go. And I stood there at the board just going like, and I thought I
Okay.
bombed it right away. I was like,
Okay.
there's no way I'm going to get hired. And eventually I kind of snapped out of it and I worked my way through the problem. In hindsight, I didn't get the best solution, but after actually asking that question in interviews, I realized
Mhm.
I did okay. So, they're tough. I think there's a lot to be, there's a lot to criticize in that kind of
Mhm.
hiring process. But I obviously made it through, and again, I was lucky to
Yeah,
have
but you
just come
took
out of school.
time,
So
2 weeks time and read the book. I mean, this is 2 weeks is a huge investment actually, right? I mean,
yeah, and again, I was really lucky to be
yeah.
able to do that. Not a lot of people can do that. If you're working already, especially if you're working and you
Mhm.
have a family, like I don't know how you carve. I have a 6-year-old now, and like I don't know how I would replicate that if I needed
Yeah,
to.
you
It would
could
be very
do this.
difficult.
The problem is only, first the motivation, then what the gained knowledge has to make a sense. If you learn just theoretical stuff which is not applicable to your work. I mean, this is the hard part. This is 2 weeks of your life without any benefit.
Yeah. Well, I've not, actually, another way I've been lucky is I have been able to
Okay.
use, a lot of this knowledge in my work. I think you see enough cases where what you would think is a pretty pedestrian program, easily has, polynomial or
Mhm.
exponential traps in it. Even for like user interface stuff, front end stuff. Um, you can easily do searches and queries and kind of operations that end up being very expensive and cause bad user experiences. So, being able to use hash tables, being able to memoize things, being able to do efficient searches and sorts, these are actually have come up,
Yeah.
quite a bit. And not getting stuck on those, being able to just, pull out your knowledge and address the problem
Yeah,
is really
this
useful.
is useful. I mean, if you learn data structure and algorithm is useful, there are less, how to call it, theoretical knowledge, which is, or there's a theoretical knowledge out there which is not particularly useful, more esoteric, I would say. But in my case, what I learned a lot because I wanted to was around 1997 Java programming certification by Sun Microsystems. The first one was really hard. This was multiple choice without knowing, how many boxes are actually right. So you had to really know, and there were no
Mm-hmm.
tricky
Mm-hmm.
syntax questions. But this helped me as well because back then IDEs were really bad. So what I learned from that is I could look at the
Right.
source code and immediately knew where the syntax errors are. I almost worked like parser back then, but I did similar approach. I also learned from books, and even longer, I think, than 2 weeks, but it paid off. So this was just for fun. I did it for fun because I wanted to. I never needed actually the certification, and yeah. What you did at Google? So you started immediately with backend services, or
Well, I got hired into the corporate
okay?
engineering department. So they build all the HR and accounting, just all the kind
Mhm.
of apps that the business needs to run. I think they also had some responsibility for like corporate IT infrastructure, not the prod serving infrastructure. So it was a really kind of interesting organization. It did a bunch of different stuff. And the first thing I got hired onto there was actually working on a compensation planning system. And there were some changes in offices there, and essentially this compensation planning system kind of got given to me as a new hire as it was transitioning, and it was a trial by fire experience because the compensation planning cycle was coming up, and I had this architecture I didn't know, languages I didn't quite know fully anymore, and yeah, it wasn't what I expected out of Google at all, and it was very intense. I was actually kind of like it was very eye opening, like how I'd never worked in a big company before. So how all of this worked, how a project got funded and started and staffed and maintained
Politics.
was, uh, yeah, it was a big shock to me, how that all worked. And I actually pitched that they rewrite the project. And so I got to be involved in kind of I would say it's a classic corporate rewrite, except for it was pretty successful. We didn't take too long and it wasn't too sprawling. But from there, I was kind of astonished that they hired, these very good Google level. We all had to pass the same Google interviews. Engineers are expensive, and they were hiring us to write the compensation planning thing, which was kind of a glorified spreadsheet. So from there, and this is my first taste of doing developer tools at Google. I used my 20% time to start a project called AppMaker.
The 20% time is a real thing, not just
It's a real thing, and it still is a real thing. You just have to take it. You have to do it. It's really nobody tells you should take your 20% time. But yeah, I took it and I started this project because right before I joined Google, I was actually doing some FileMaker consulting. I knew a bunch of people who had started small businesses and made these databases and kind of hit a wall with their knowledge of how they did the database, and I would come in and fix it for them. So I kind of actually was enamored with the power, the ease of use of FileMaker for like non-programmers. So I started something very inspired by that, but based on the web and App Engine. And I did that for a few years. That eventually launched as an external project called Google AppMaker. And unfortunately, it's shutting down this month, which, yeah, it's another member of the Google graveyard, I guess. But yeah, it was public for a couple of years. It was used very heavily internally also. Yeah, so that got me interested.
What was it exactly? So Google AppMaker. So what you could do with it?
So it's an application builder. I would say it falls under the low code umbrella. So there was a drag and drop WYSIWYG UI builder. And then there was a data modeler where you could build up a schema. You could also connect to a couple of other different database types. There was SQL and some internal databases. And it had, one-click live preview and a one-click deploy. And yeah, it let, tons of people, especially in HR in the area that Core Bench was working, to create their own applications very quickly. And there was another effort in Core Bench too to create like a common corporate database that had like all the information the company needed to run. So once we supported that, you could basically start building, your own HR apps like anybody could. So we just had the HR business people start making their own applications.
Yeah, this is actually incredible. So in your first job at Google, or even with the Google AppMaker, which programming languages you used at Google back then?
It was entirely Java, even on the client. So we used Gwt.
Okay.
Google Web Toolkit for those who don't know. And that was my introduction to Google style web programming, which turned out not to really be Google style because there were other Google styles out there. And it worked. I mean, it was a time when like is an interesting word to apply to Gwt.
I tried to avoid that. It was also very, I would say, popular outside Google. So some of my clients wanted to use Gwt, but for me it was, if this breaks, I have no chance to fix it. So I say, okay, then I cannot help you. This was like.
Yeah, I mean, when we hit the big enticing thing about it was, one, it brought power and structure to the web that JavaScript didn't have at the time. and it brought a type system, and we felt more confident that our code was going to work. Um, the other big thing was sharing code between the server and the client. Node did not exist yet. I'm not sure Chrome had even come out, or maybe it had just come out. I mean, this was right around the time when V8 would have even been starting. So JavaScript, wasn't that fast. You wanted to optimize the compiler. So it really enabled us to do some interesting stuff. We were running JavaScript via Rhino on the server
from Firefox
inside of Java, and that let us do some interesting things like wire together. We could expose parts of our Java API into the Rhino environment. We also built a real-time editing system, an operational transform system, so two people could edit the app at the same time. And a lot of that was based on shared code between the client and server for representing how operations were made and applied to these documents. So it worked out pretty well. I think, a few years after that, when better frameworks came around for JavaScript and JavaScript advanced a little bit more, you could see that Git was more of a hindrance than a help, and it slowed things down. But at the time, I think it was a decent choice.
So what happened? Or you stick with the Google AppMaker, or?
No, I left that after a few years. I had a very kind of grand vision for that concept. And it was very difficult to get a grand vision funded to the extent that you feel it deserves when it's kind of your baby like that. So
one may think I get everything funded at Google, right? So this is what. So let's say.
Yeah, this is not how it goes. But I was enamored with making development better and easier and more accessible. And around this time, the Dart programming language project started up at Google as well. And I knew people who knew people who were on that team, and the Dart team had done kind of a roadshow and done these hackathons, and we invite people to come in for 2 days and build some programs and tell us what you think of the language and find bugs and whatnot, that kind of thing. And I had convinced my AppMaker teammates to go with me and just real quick try to build the simplest AppMaker clone we could in Dart. Because we were already feeling the kind of limitations of Git and how heavyweight it was. And so at that point, I really kind of fell in love with Dart, and I ended up switching to the Dart team for a couple
years. Dart is actually a nice language. So I saw Dart. I used a little bit with Flutter. And I always was interested in Dart, and it looks nice, and it was immediately understandable for me as Java developer, right?
Yeah, I kept telling people that it's about 2/3 of the way between JavaScript and Java, but leaning more towards JavaScript. So that was really nice. I mean, I think at that time, I just from working with compiler developers and language designers. I learned a whole lot about programming languages. That was really a great time there, and I wrote some more parsers. They're actually used as part of like polymer Dart. I got to do JavaScript interop, so learned all kinds of things about the difficulties of translating things between two programming languages. So that was really great, and I was there for about 2 years. I worked on Polymer Dart and JavaScript interop, but that's where I got introduced to web components. Was when I was on the Dart team.
What I heard is that with Dart, with respect to Dart, at the beginning, so Google had their grand plans with Dart. So this should be the language which should replace JavaScript, even, right? So I heard some interviews. They say, okay, this should evolve and become the language. Was it their plan, or what was the purpose at using Dart at the beginning? You remember that the goal back then?
Yeah, I mean, I wasn't part of the Dart kind of the initial project starting, right? But it was started by people who had implemented the fastest JavaScript interpreters, the VMs at the time. And, I think it came out of a frustration of kind of the slowness of JavaScript's evolution at the time. A lot of the perceived, mistakes in JavaScript design that couldn't be fixed without a breaking change. And then also from the point of view of, these VM authors who wanted a language that was easier to write a VM for. So yeah, they did want to integrate Dart into Chrome, and there was famously a version of Chrome that had the Dart
Okay.
VM in there
Okay.
called Dartian. But Google is not a uniform place. I mean, not everybody had that same aspiration or agreed with this. So there were different groups of people kind of working towards different goals there. But it was kind of a stated goal of integrating the Dart VM into Chrome and making it, play right alongside the JavaScript VM. No, that definitely was an aspiration of some people. That I think has gone away now, and the approach now is to only compile Dart to JavaScript, and then I think a ton of the focus is on Flutter these days, where they have more control,
which is really nice. So after you manage to install it, it really works smoothly.
It works smoothly.
Yeah. At the beginning, I couldn't believe, how much it takes. This is not the fault, of Flutter, but you have to, after you install the Xcode and everything, I think you will have to download, 5 gigs of runtimes until you can ship. Yeah.
Oh, sorry. I left the Dart team right as Flutter was starting up, so I never really wrote any Flutter code. But I like the architecture of it.
It works after it's installed, works perfectly. So another question what I heard is that at Google the Angular on Flutter is actually, on Flutter, on Dart is fairly popular. So Google uses internally a lot of Angular Dart projects.
Yeah, I mean Google uses Dart a lot internally. It's been a while, so we had Polymer Dart for a while. That's what I worked on. I don't think anybody is using that anymore. So basically, there were these initial ideas that maybe we could find this kind of universal system. I think it was very idealistic at the beginning. And then from even those same set of people who thought, they could do that, things diverged into a couple of different groups. So you have Angular Dart is very popular, especially in the ads group. And then you have Angular 2.0. I guess I always forget if AngularJS is the old thing.
Is the old thing.
Whatever they call. Okay, yeah. The Angular 2.0 and everything since then was kind of based on a lot of the ideas that were used for the original Angular, actually. So then you have a bunch of people doing TypeScript and Angular. You have a bunch of people doing Polymer and lit element and web components. And then probably even larger than all of those is an internal non-open source framework that we have. That a lot of
what is the name of the framework?
So there's a bunch. It's called Wiz. I believe that's been talked about publicly.
So Wiz is the most popular framework, and then what is the second one?
Probably Angular. I believe I have this right. Yeah. I mean, there's a lot of developers at Google, and things change quite often. Yeah. So yeah, Wiz is a very, very interesting framework. It's kind of unlike anything else. It's almost not even a component-based framework. It's a very interesting framework in that it kind of forces you into this server-side render, incremental hydration, incremental code living thing. So you can basically have a team that's very large, and you're almost guaranteed to have good loading performance because the framework doesn't let you load arbitrary JavaScript for the initial page render. It's against the rules. So it's a fascinating thing. I think both the Angular team and the Polymer Lit team definitely look towards Wiz as it'd be interesting to add those types of features to our products.
Wiz is W-I-Z. This is how it's. Okay, that's the Wiz. Okay, interesting. So, but you started at the Polymer team. Was it the recent Polymer or the old one? So I think, the ES6 based, or just what happens before?
Yeah, so I joined Polymer right before 1.0 went out. And I actually joined them hoping to do a UI designer for web components. So I was kind of on the side doing this research project for that for a while. So yeah, that's when Polymer 1.0 came out, and it was based on the old web component specs, what we call V0. And it was based on HTML imports instead of JavaScript modules. JavaScript modules weren't even a thing yet when we did that. So then I did tools over there, and after being part of tools, our big push there was to try to not have to do tools, just do only what was necessary. And mainly those things were necessary because of HTML imports. Like no other tools knew how to understand an app being built out of multiple HTML files like that. But as the other browsers and Google collaborated on the new version of the web component spec, and it was clear that HTML imports were not going to be included in that, we helped with the transition from HTML imports to JavaScript modules.
What is your take on that? So you like the imports better, or you are happy with ES6 imports?
I'm a little torn here. I'm the kind of person who wants to, always try to have the best of both worlds. So I do think having a single module graph, a single dependency graph, is very important for developers, for the platform, and for tooling. So once it was clear that the module systems were slightly different between HTML imports and JavaScript modules, it seemed way better to go all in on JavaScript modules and then start expanding the type of modules you could load in the JavaScript module graph. And so that's where there's a new proposal out called HTML modules, which lets you import HTML from JavaScript. And before we even get there, there's two that are making really good progress right now. There's JSON modules and CSS modules. And I'm particular, I think I started the CSS module proposal. I'm a huge fan of it, obviously, and I think it's really important because the thing you want out of your dependency graph is you want every module to be able to describe its actual dependencies, the things it needs to load and run, not just the JavaScript ones. So once we have CSS modules, you'll be able to say, if I load this component, I'm going to get its CSS. And that's just going to work in a standard way. The browser can do it without tools, or tools can understand the dependency graph and optimize it as well.
Yeah, exactly. So in my current project with I use lit without HTML, just the lit HTML without the element is what I wanted to say. And so my components look like almost Java classes, and what's lacking, of course, is the CSS dependency, right? So you have two choices. You will have to load, the CSS as a style tag from somewhere into the shadow DOM, or you skip the shadow DOM and define everything with BEM syntax or something on top. So this is the choices right now. It would be nice to have, be able to load CSS stuff, right?
Yeah, I mean, and what we're hoping is that people get to structure their components the way they're laid out in multiple files or not, like, according to their preferences. So some people really like, lit element has this template tag for CSS. So you write CSS backticks right in your component. You write HTML backticks for your template, and it's a single file component, but it's all in JavaScript, and it doesn't require any tooling to build or load it. And a lot of people really like that. On the other hand, there are a ton of people out there who want to write CSS in .css files, and HTML templates in .html files. So CSS modules and HTML modules would give them that ability. And that especially would help, I think, people be able to use other tools. So like, let's say you could use Sass to write your CSS. You compile that into standard CSS and load that via CSS modules. Or you use Pug or something to write your HTML templates if you wanted to. Compile that into HTML and load that. So, hopefully everybody we can have the best of both worlds, and everybody can choose the style that they want.
So you actually started lit HTML, or?
Yes, I did. Why? Yeah. And it's related to the JavaScript modules thing, actually. So we wrote a translation tool to translate Polymer 2 files from HTML to JavaScript modules. And in Polymer 2, the template kind of was the container. And inside of your HTML, you would have a script tag. So HTML was the container, script was inside. So what the tool did is it inverted that, and now script was the container, and we had to put the HTML inside of it. And in Polymer 3, we just have that as a string that's given to your class with a static property. And inside that string, you have expressions. And these are just Polymer expressions that have kind of the same style that have carried over from Polymer 1 to 2 to 3. But those expressions end up referencing JavaScript properties and JavaScript variables, right? Except for that no tooling understands that it does that. So in order to get code completion and syntax highlighting and type checking and stuff, we have to write custom tools all over to get it to be able to understand those expressions. And I just thought that was really unfortunate. And, I was looking into template literal syntax and the fact that you can have expressions there. And so lit just came out of a need to basically make what was inside those curly braces actual JavaScript. And it was kind of an experiment over a couple days to see if it could work. And actually, the first versions of Lit were a thin layer on top of Polymer.
And were you actually were you inspired by the HyperHTML back then, or
not really? Polymer already had a system that basically took expressions and made placeholders inside of a template element, and then piped the expressions into those placeholders. So I was already trying to do that with templates and tag template literals there. The one place where I didn't understand actually that HyperHTML worked that way, because it wasn't quite like obvious in the way it was described. But the one thing somebody else who had tried it, gave this tip and said like, well, tag template literals are actually like non-obviously powerful in that when you have a template tag function, if it's called multiple times, the same template tag function at the same location, that the strings that are passed to the function are referentially identical. It's the same strings object you get every time. And you can use that as a cache key. So if you have expensive work, like parsing the HTML of a template, you can do that the very first time that you see a template and cache it. And then every other time, either a repeated render or another instance of that template can be cheap. And so, somebody who had looked at HyperHTML told me like, oh, tag template literals can do something special here. And then basically that's all that's needed to go ahead and build this type of system. Because the key thing you want to be able to write an expression in the template, but you need to be able to evaluate that expression over and over again to get the new values. And so one thing we had actually played with at the time was before we realized tag template literals work that way, we had written expressions as functions, small closures. And that way the system underneath could take those closures and execute them as many times as they want. And we felt that was ergonomically not the best. But one thing that's really interesting is a new framework that's kind of inspired by Lit has come out from Microsoft called Fast. And they actually do it that way.
And they even have, I think, fast components,
your expression.
Right? There is fast and there is fast components. They have own fast web components, right? Is it this?
It is. I think there's 3 parts to Fast. I think there's there's like a templating library, a base class, and a component set. I think that's.
I took a look at the component set,
so
but they were not as vanilla as, let's say, Vardin, where you can just use them. There was more a part of a larger framework, looks to me. So it was not like as easy as, just load it as an ES6 and just use it. So some tooling were required last time I saw it.
I don't know. I thought they were distributed as pretty standard JavaScript modules. They are implementing Microsoft's design system. I can never remember if it's Fluid or Fabric. The name of it, but I do think that they have an interesting theme system in there where there's some kind of provider system that maybe acts like React Context or something where you can actually pretty significantly change the theme of all the components in a subtree. So they might ship with a very kind of Microsoft design system look and feel out of the box.
But I think they always roll up and see what happens, and it didn't work. And that's okay then. Usually I tried with SAP UI5 and Vardin, and they just work out of the box. And this one was a little bit heavier, so I would have to reevaluate this again. But I saw the keynote. I think it was Google I/O where Lit HTML was announced, and I remember it fit in one page on one slide. So there was like were you on? I don't know whether you also attended the keynote, but I don't know who it was. But you saw the entire source code of Lit HTML on one slide, and they mentioned this ES6 literal, and this is what I thought. This is incredible because the problem in enterprise is the dependency on a framework. So usually every 2 years you have to migrate, and if you have a large company, the problem is there is no budget to migrate, or it is really hard to find budget to keep the framework up and running. And the framework is usually not the problem, the build system. If you wait too long, the build system is out of date and you cannot build anything to release. But with Lit HTML, I say, look, if this fits on a slide and we find an error, we were probably even capable to fix the error. This is not like it's a magic. And this is where I started with lit HTML, and it worked actually better and better over the years. And now I have to say, feedback to you, is hyper productive with lit HTML. It's incredible what you can achieve with that. Mm-hmm.
Yeah, thanks. Yeah, I mean, I'm really happy with it. When I get a chance to actually use it and write components and apps, it feels very nice. Yeah, I think that was a slide I had made. At the time, lit HTML was about 2K in size. We've added more features, so I think it's close to 3K now. But I'm sure with a couple font size adjustments, we could get
you
it
have
in a
more
single
resolution
slide.
right now, yes?
Yeah, exactly. Yeah, and speaking of lit HTML and the size and everything, so currently we're working on the next major versions of both lit HTML and lit element. And so we're doing a lot to make it smaller still, and make it faster again, and even add some new features on top of that. So yeah, it has worked really well. I mean, we announced it in 2017, and so this is our first breaking change that we're doing. And it's not even a very big breaking change.
What will happen? So what I will
Very
have to fix
few
in the
people should be.
projects?
So for most people, for lit HTML, there should be very few breaking changes in some details of things. Maybe the way arrays are handled in attributes, or if for some reason you're passing symbols to an expression, that won't work the same. So there's a couple of very small differences. The big changes are that we're dropping a lot of the customizability of it. In some ways, lit HTML 1.0 is a template system construction set, because you can write your own template processors and template factories and really customize the syntax and do all kinds of stuff. But we found that abstraction was costing code size and a little bit of perf, and very few people were using it. And it also kind of got in the way of SSR, in that when we're doing SSR and hydration, we have to assume a certain structure to the bindings. And if you did something wild in your template processor, it wouldn't work. So for all those reasons, we decided to just remove the abstraction and simplify
what do
the
you
core.
mean? The HTML and render and all the handlers at click and so forth, and the syntax is the same? There's
all
no
of that is the same. Mm-hmm. Yeah, we have this. Yeah, we have the same directives, the same syntax. Almost all the value types behave the same way. So for most people, it probably won't even be a breaking change at that level. If you've written your own directives, the directive API has changed. And I think it's going to be a simple upgrade. And the new directive API plays with SSR a lot better. So most directives should just kind of transparently work in SSR with the new API. And then lit element has a few small changes as well. One of the big changes is we're changing how we support Internet Explorer. So for Internet Explorer, we have the web components polyfills. And then we have the core libraries, and there's this kind of bridge between the libraries and the polyfills, so that for CSS scoping and for Shadow DOM, that we can kind of call into the polyfills to make them work. And that bridge was always bundled in with the core libraries. And so what we're doing in the next version is we're making that bridge a separate file. So by default, we won't support IE. And if you want to support IE, you got to load this separate. We call it a platform support file.
You mean the old IE, right?
And if you do,
not the IE based on Chromium, rather than the I.
Well, when I say IE, I refer to like not Edge, but actual Internet Explorer.
Anyway, I would say.
We still have a lot of customers who need to support
in recent projects
IE.
in Europe, huge customers, we didn't ship any polyfills. We just ignored the Internet Explorer, and the business department were fine with it. So this was interesting. So this is just feedback to you. So we shipped actually vanilla ES6 without any transpilations, and it just worked. Yeah,
that is awesome. I mean, I think our next breaking change after this one, I hope we can finally drop IE support. But we have customers who themselves have customers where they're contractually obligated to support IE. Especially people who support government and healthcare. They'll have these contracts that and so they don't really have a choice. And we figured out a new solution that hopefully makes it no impact on modern browsers. So you're never loading the code to support IE, but still supports IE if you know how to set it up correctly. And so we think that's a pretty good medium ground.
Question regarding lit element. So I'm using straight lit HTML. I never saw, the added value of lit element for me. So what is, the killer feature of using lit element over just plain lit HTML for you?
So lit element is really based on this base class that sits directly under it. That's currently called updating element, and we're renaming it to reactive element. And what that base class does is it gives you a kind of richer lifecycle than what web components have out of the box. So it gives you this update lifecycle where it will batch changes that come in and then kind of render those changes to the DOM all together at once. And so it gives you reactive properties. So when you declare these reactive properties, it will create getters and setters, and the setter will trigger the update lifecycle. And it does the batching. And then it also does like reflecting to attributes for you and a couple of things, but it's mostly around this reactive lifecycle and these reactive properties. So lit element basically takes that and bridges it with lit HTML, and it says, okay, what we're going to do when there is an update is re-render the template you get.
What I do, what currently in various projects, also in larger projects, actually in one huge project, we are always combining lit HTML with Redux or Redux Toolkit. And what happens there is that we have a base class, which is probably 50 lines of code, JavaScript code, no more. And this class subscribes to the Redux store, store subscribe. And every change just renders the view. And because the lit HTML detects, the changes, it is very fast and very simple. So on every change, all the components gets re-rendered. And this is the way, the architecture is working. And right now it was very simple, no problem so far. And yeah.
Yeah, I mean, this is the thing I like about lit HTML and lit element being these pieces that connect together in that way, is that if you have some other way to get your data changes into your element, and then you have some defined point where you can call the lit HTML render, you can do that. And, you were talking before about needing to switch frameworks a lot. A huge part of our philosophy these days is having a very low lock-in. So that goes both to, web components in general, is that, you should be able to mix and match web components from different libraries. That decreases lock-in. It goes to our tooling story. We really just want to be plain JavaScript as much as possible, so that you're not locked into a very specific tool chain. And it also goes to the library source code themselves. Like, one of the advantages of having these libraries be separable and also having them be small is that, you can use lit HTML without lit element if you want. You could use reactive element without lit HTML. They're also small enough that you can get in and fix bugs and contribute if you want. Or if we were falling behind and not doing our responsibility with maintaining the libraries, you could fork them or write from scratch your own code that does something very similar. So I think that's a huge thing for a lot of customers. Is maybe they don't want to maintain a library like lit element, but as long as they feel like they could, that gives them a lot of security in terms of thinking about the future.
Is easy to explain, There's not lots of, transpilation and magic going on. So this is like, basically you can start to explain there are two functions, HTML and render, and this is what happens. And everything else, builds on top of that, which is great, actually. This is, I would say, almost a Java approach, It's completely different to usual, JavaScript frameworks where you have code generators and transpilers and some stuff I would argue really no one understands anymore in the entirety. Another thing I heard a lot, I never understood because I do the opposite, is that the web components are actually not suitable to build applications with them because they are too coarse-grained. To fine-grained. So the components are built for visual elements. And what I do actually with web components all the time, I use web components to structure the application. So I use a web component like navigation, view, header, footer, even router is a component. And inside the top level components, I have my finer components, and sometimes I have my not button, but let's say a smaller parts. But usually I start with coarse-grained big components, which I name, just by views. And this is the entire structure of the application. So what's your take on it? So you also see this, the race of components to structure applications, because I don't understand why I need still a framework. Because if you do this way, it is very simple. And I did it a lot. I just, showed at conferences or even my clients, Swing Java developers. I don't know whether you remember Swing or AWT. I showed them, this JavaScript with lit HTML, and they got it. with grid layout. We have the CSS
Yeah.
grid was combined with that, and everyone was on my side. This is actually great. The first time we understand, what's going on.
Yeah, I mean, I've given talks about this, so I definitely agree that you don't need a framework. But it is interesting to kind of break down what people mean by that when they say you need a framework, and what they imagine is lacking from the web components kind of oriented system. And I think usually what it comes down to is kind of element coordination or component coordination. That some people see the framework as having this role of passing data between components or creating communication channels across component trees, or like you said, routing, or like what are some other things that they partial rendering, asynchronous rendering, things like this, optimizing, what parts get rendered. And it turns out really that you can do all of this stuff without a framework. Like with lit HTML and lit element, what we do is we pass properties down a tree. So a parent component will assign a property on a child, and then the child will react to that changing and re-render if necessary. And so that gives you your downward data flow. And it's not tied to any framework. Any web component that has a setter for a property will just work. And lit HTML shows how your template system can set that property, and there's other template systems that can do that too. In terms of cross tree coordination, it's quite easy to use DOM events to communicate back up the tree that some user event had happened or that you need to provide or fetch some data. Routing is very easy to do. I tend to do routing still in the JavaScript layer, but you basically are deserializing the URL into some data, and then you feed that data back down the tree. State management is quite easy to do with Redux or MobX.
Funny fact. So with the router, I started with a mobile app, so it should mimic the native experience, and I used a Vaadin router, which is great, which is based on web components, and the big deal of routers, having readable URLs, and what I saw the app there is not even visible, because if you have a native app on a mobile phone. So there is no URL which is visible. So it shouldn't be visible. I use, the manifest to install the app. So I ditched the router and I just load the components by their name. So what you can do is you just replace a DOM event. And if the component disappears, disconnected callback is called. If it comes, it's connected callback. So you don't even need a router for mobile apps. So routers are more interesting if you would like to have readable URLs for websites, but for mobile applications, in a full screen mode, you don't even see the URL, right?
Yeah, and so I think another category of things comes down to the difficulties with shadow DOM styling. Is that some people are still trying to style the app at the top level with a single style sheet. And that's generally solved by showing people how they can load style sheets and share them across components and load them into their shadow DOM in multiple components. And then what you have is a style sheet that a bunch of components load in, and now you have application styling. And then a last category of kind of coordination, is that there are some things that if you want to communicate across components, you need some kind of convention for. A good example of this would be if you want to do something like suspense with React, where if you want to let some subtree render asynchronously and kind of notify when it's done. And you can do this with events. You can have a subtree fire an event that says it has some pending work to do, and it will fire another event or resolve a promise when it's done. And if you have this convention around this pattern here, you can have components that don't show a subtree as it's rendering and show a spinner instead, and do all the coordinated kind of things that the React suspense demos have shown. And so one thing we're trying to do to address that is that it's all possible, but you need this convention. So we're starting up a repository in the Web Components GitHub org to store just documentation of these conventions. And so hopefully the idea will be that multiple components and multiple web component libraries can implement these same conventions, these little micro specs in a way, to replace some of the coordination functionality that you would get from.
So you also see, the uptake of vanilla web standards apps, because I'm largely involved in enterprise projects, bigger companies, and this is obvious. This is an obvious trend, because they really would like to get rid of all possible frameworks because of the dependencies. And with that, I would say, if you use web components and combine them with lit HTML, it really looks like React, right? So this is
Yeah.
I mean, from a productivity perspective, this is not a huge difference. You can even apply, the same patterns from React to web components with lit HTML. So even how to structure Redux, how to slice it, how to deal with forms and validations. For me, it looks almost the same. So I would expect, 2021 or 1 year later, a bigger trend towards back to the roots. How web, started 20 years ago without any build tools and compilers or whatever, right?
Yeah, I mean, I vary myself in the how dogmatic I am about these types of things. And right now, my read on the situation is that like I think there are a lot of people who want to be more vanilla, and they can right now. But there's not like a single place that kind of tells you how to do this, right? So that's one thing kind of a framework gives you is they can like give you the recommended structure and all the documentation in one place and tutorials and starter kits and really an ecosystem of people who view things the same way. Vanilla is a little different because you don't necessarily have that. So I think we're entering a phase where people can choose to be completely vanilla if they want to. But for a lot of other people, I think maybe it should be basically like maybe they should prefer being vanilla where it's
Yeah.
pragmatic for the time being, right? And ideally choose to work with projects that are kind of aiming towards a future where things are less proprietary and more kind of built into
Yeah.
the platform, which will mean that we can use some roll-up transforms now. We can use some fancy, dev server build thing for the moment. But what we're aiming for is a situation where, these features that people need to
Mhm.
be productive end up being in the platform, and then they have less
Yeah,
lock-in over time.
but you said dogmatic, but from I mean, not even dogmatic. If you think about that, the browser understands JavaScript and HTML. So if you start learning web it just with JavaScript and HTML, this is what browser understands. And if this works well, there is no reason to take to pick a framework. I would say what could remain a framework as a set of patterns, naming conventions and styles, like a community more. We can go the web standards vanilla route, and there is no this reactive way of doing things and component base of doing things, and maybe whatever. So like just communities, but there will be less and less the usage of or the need to have a framework, right?
Less and less over time. Yeah, I mean, I think the key for me though is not being so extreme one
Yeah.
way or the other that you cause difficulties in the present. Like to give a concrete example, um, the browsers support loading JavaScript modules right now, right? So you're like, great, we could send JavaScript modules to the browser. But there are a lot of kind of downsides to that. I mean, the first thing that you hit is that browsers don't support bare module specifiers. So you can't just like
Mhm.
import Lodash, right? You have to
Mhm.
import a URL. It has to
Mhm.
start with a dot slash or something like that. So when we published our JavaScript modules, we had a big debate on the team about how to do this, but we ended up saying, okay, even though browsers don't support it right now, we're going to publish bare module specifiers in some of our imports. So like lit element imports lit HTML just by saying import
Mhm.
quote lit HTML. And that requires that you build the lit element modules before the
Mhm.
browser sees them. And you can do this very cheaply with a dev server that just knows how to do node module resolution, but it does require some build step. It is something the
Mhm.
browser doesn't support. But we felt that that was such a productivity gain to be compatible with the entire tool ecosystem in Node that that was an acceptable trade-off for the time being. And then in the future, which is actually the present now, I think the next version of Chrome is shipping with
Okay.
import maps. And import maps let the browser know how to deal with these bare module
Mhm.
specifiers. So that's kind of thing I'm talking about where you want to lean towards uh, no required tooling, no required framework. But in a case where it's really pragmatic and there's just no other great option, go ahead and try to choose something that requires some tooling or something, but in the future won't. I think CSS modules are another great example of this. Um, it is very important for people out there to have their components and their JavaScript libraries be able to
Mhm.
load CSS, and the platform doesn't have a great solution for that. So what we've tried to do with Lit Element is plan for a future with CSS modules and be able to support the thing that you import from a
Mhm.
CSS module
But
like
this is
already.
more like utility, not for me a framework. It's more like you are not using the plain standards everywhere. You're very pragmatic. You know, I don't use the JS imports. I use my bare imports in this particular case. But it's not like you are inventing, a new language, new framework, or whatever. So it's more in your library. You are picking and choosing things which are proprietary but may disappear in future. By the way, this was the entire idea of Polymer, right? So that the framework started as a framework, but should be should how to call it, disappear, over time and be replaced by standards.
Yeah, I mean definitely. But I would say like Polymer was never a framework, because the framework is the thing that instantiates the components, that hosts the components. And even in Polymer, even though it was a little more heavyweight than a lit element, it never was the component host. The browser was the component host. But yeah, Polymer definitely had an idea that some of the aspects in it, like the template syntax, might go into the browser one day. And there were even kind of proposals and prototype implementations. Like there was this thing called MDV, model-driven views, and the template system might be in the browser. Yeah, again, I think that's like, I'm somewhere in the middle on this now. I'm not sure if we'll ever have enough consensus to get everything that's, say, in lit element and lit HTML like into the browser. Like hopefully we'll have native decorators at some point, and maybe once we do, the browsers will have some decorators to help you reflect attributes. Maybe we'll get the template instantiation proposal, and the idea of recording dynamic parts inside of DOM that can be updated will be in the browser. I am not sure we'll ever have anything like HTML backticks in the browser. I don't know if there would ever be enough consensus for that. So I think the key is getting the platform to the point where it's cheap and easy to build the little sugar layer on top that makes the developer experience really great.
Lit HTML right now, I mean, there's basically two functions which are well integrated with the Java standard. It's not like a hack or a preprocess or whatever. Just basically HTML is the ES6 literal, which is like a hook to the standard JavaScript ecosystem, which is not a big deal, I would say. This is already a standard way to extend JavaScript, right?
No, it's great. I mean, it's small and fast. If things didn't progress further than this, it would not be the end of the world. But lit HTML still does some runtime template processing the first time it sees a template. It parses that template string a little bit to figure out what kind of marker to insert, and it inserts these markers. And it definitely does some stuff that would be nice if primitives for that were built into the platform, and then lit HTML could be even smaller and faster. And more importantly, that means that if somebody was using lit HTML and somebody else was using fast and somebody else was using stencil, the more those libraries can shrink, the less overhead there is for using multiple libraries on a page. And I think that's going to be important to get to too. Once we have this rich ecosystem of components that you want to pick and choose, you don't want to have to limit the component you pick by what library it was built with.
And lit HTML and lit element are actually also used inside Google, right? It's not.
Yeah, quite a bit.
So
yeah,
quite popular. And which I mean, really popular, or no? Just a few departments. Or I mean.
Somewhere in between. I mean, it's not nearly as popular, as Angular internally. I would say, a lot of stuff got built on Polymer, and so Polymer might actually still have more kind of absolute raw usage than lit element. But the growth curve for lit element internally looks really good right now, and especially the satisfaction of the developers using it. So. We're seeing a lot of people pick it up for new projects, and a lot of people converting the Polymer over to it. Chrome still has a lot of usage of this stuff in. Well, I shouldn't say still. I mean, like the Chrome OS, a lot of Chrome OS apps that are shipping with the operating system are being built with lit element. Chrome DevTools is being built with lit HTML somewhat. I mean, so there's a lot of stuff going on. I think. One way we know that we have something that's good here is that when people try it, they want to use it more. They don't want to give it up. So yeah, we're seeing really, really good growth. And we're also trying to figure out ways that we can break down these silos within internal Google frameworks. That's our mission with web components. So we're trying to think long term and see how we can make that happen between the Google frameworks.
Even Java developers like me, like lit HTML. So thank you for your time. So where people can find you on lit HTML?
Yeah, thanks for having me.
on the internet. So,
well, probably the best places are the websites and the Polymer Twitter handle. So at Polymer. So we're the team. We don't just make the Polymer library; we also make all the lit libraries. And then lithtml.polymer-project.org. Probably just easiest to search for lit HTML. That's our website there, and there's a separate website for lit element. And then we have a Polymer community Slack channel that a lot of people hang out on. And you can find that on the websites there. There's a link to join.
And you have also a Twitter account, right?
Yes, I do. Justin Fignani is my Twitter handle. It is probably like 95% politics these days, so I'll give everybody a fair warning. I do tweet tech stuff, but if you want politics free, go for the Polymer
Thank you a
account.
lot. I really enjoyed the conversation about how lit HTML happened actually.
Yeah, me too. Thanks for having me.